There are over 1 billion cars in use around the world today. Today, you got in a car, turned a key, and suddenly you had the power to get here. This is all thanks to the internal combustion engine, or ICE for short. As a mechanical engineer who works on cars, I have had my hands on about a dozen or so engines, and I always get asked, how do these things work? And I always answer, all car engines have the same basic set of principles that allow them to run. Today, I will show you the four-stroke cycle, the laws for perpetual motion, and the external systems that help maintain the engine. The primary function of an engine is the four-stroke cycle. Four-stroke cycle was invented by Nicholas Otto in 1862. According to the Encyclopedia of World Biography, Otto notably added the compression stroke to existing engines in order to improve efficiency and power. By 1885, the first car with an Otto engine was made. The cylinder is made up of the piston, the connecting rod, the crankshaft, the valves, and the spark plug. According to the McGraw-Hill Encyclopedia of Science and Technology, the four-stroke cycle is in the following order: intake, compression, combustion, and exhaust. Intake is when air is sucked into the cylinder from the intake valve and mixed with the fuel as the piston moves down. Compression is when the piston pushes the air-fuel mixture to the top of the cylinder and compresses it. Combustion is when the air-fuel mixture is ignited, causing a rapid expansion of air molecules that pushes the piston down. Exhaust is when the piston pushes the air out of the cylinder through the exhaust valve. This cycle moves the crankshaft, which converts the up-down motion of the piston into rotary movement that spins the wheels. Now that we know how the four-stroke cycle works, let's look at some of the parts that make it possible. In order to achieve perpetual motion, the engine needs 5 main components. The 5 main things an engine needs in order to run are fuel, air, spark, compression, and timing. An engine uses fuel injectors to squirt the right amount of fuel into the cylinder each time. Direct injection squirts fuel directly into the cylinder, while port injection squirts fuel into the intake manifold. To effectively burn the fuel, the engine needs a lot of air. According to the Automotive Reference Book by Paul Richards, for every part gasoline, the engine needs 14.7 parts air in order to burn it. Compression is necessary to mix the air and fuel together to provide a greater combustion stroke and to add movement to the combustion stroke. Spark plugs create the necessary spark and ignition for the air-fuel mixture to explode. Power is sent from the battery to the ignition coil and to the ignition control module, then to the ignition coil, and then to the spark plug. The alternator takes engine power and converts it into electricity to recharge the battery. The last necessity an engine needs in order to run is timing. Timing makes sure everything is running at the exact correct time in order for the engine to start and stay running. Timing is controlled by the car's computer and the timing belt. To improve the longevity of the engine, the car has a few systems in place. The camshafts, lubrication, exhaust, and cooling systems of the engine to continually run. The camshaft is a metal rod with cam lobes on it. The job of the camshaft is to push in and open the engine valve at the right time in order to allow air and fuel into the cylinder and remove exhaust. The camshaft sits above the engine valves and is connected to the crankshaft by the timing belt. The timing belt makes sure the camshaft stays in time with the crankshaft. Lubrication, cooling, and exhaust systems are also important to the longevity of the car. Motor oil is pumped to all the moving parts of the engine in order to prevent metal corrosion. According to the study of motor oil cooling in the SAE International Journal, motor oil is also used to cool and clean the engine. The cooling system works in tandem with the motor oil to pump cool water around the cylinders to absorb heat. The hot water is then pumped into the radiator to cool down and then is pumped back into the engine. The exhaust system carries away the exhaust gases away from the engine. A catalytic converter removes the harmful gases from the air before sending it out into the world. In conclusion, I shared with you the four-stroke cycle, the laws for perpetual motion, and the external systems that maintain the engine. Those basic set of principles allow all car engines to run. The internal combustion engine is a magnificent piece of technology that will continue to power our world for generations.